Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of Energy. Remember that this biomass energy course has 9 lessons. Lesson 2 is divided into 2 parts. This first part is dedicated to defining the properties of biofuels and their quality standards. Let's start answering the question about what are biofuels' main properties. Biofuels can be solids, liquids, or gases. For example, straw, firewood, briquettes, pellets, and charcoal are solids. Bioethanol, biodiesel, and pyrolytic oil are liquids. And biogas and synthesis gas are gases. Briquettes are made by compression of organic materials like agricultural residues in order to burn longer and make transportation of them easier. Wood pellets are made from virgin wood dried and pressed into small cylinders, without additives aiming to have standardized properties. Charcoal is the black carbon residue produced by removing water and other volatile constituents aiming to increase its energy density. Let's tell you a story to better understand biofuels' properties and quality standards. Jane is a junior engineer working for an energy services company. She has been challenged to design a biomass-fueled facility fed with solid biomass. From her experience, she knows that fuel characteristics are essential for calculating the fuel consumption, energy efficiency, and environmental impact. She also knows that the quality of fuel strongly influences the performance of boilers. When using natural gas, Jane has used the data from the company to know the heating value. Even when working with biogas, it was not so difficult. Making an analysis of the gas composition, she could easily calculate the heating value of a mixture of gases. Just multiplying the heating value of each component by its molar fraction and making the sum for all components was enough to calculate the heating value of the mixture. Aha! Jane remembers well her lesson at the university about this topic.
The heating value is the amount of energy released as heat when a compound undergoes complete combustion with oxygen under standard conditions, that is at 25 Celsius degrees and 1 atmosphere. Obviously, the heat released is the one needed to cool combustion products until 25 Celsius degrees, their initial temperature.
Then, Professor, this is the maximum amount of energy we can get for a kilo of fuel?
Depends.
What does it depend on?
It depends on the final state of water. If the water of combustion is allowed to condense to provide liquid water at 25 Celsius degrees, then you have the higher heating value. And this is really the maximum amount of energy you can get.
What about not condensing the combustion water?
Then, when the water of combustion remains in the vapor phase, we have the lower heating value. Tell me, Jane, what is the difference between the higher and the lower heating value?
The difference between them is the enthalpy of vaporization of water formed in the combustion.
Absolutely. You've got it. In most of the commercial boilers, water in flue gases is not condensed, so you can use the lower heating value as reference.
Then, Professor, when calculating the energy released in a boiler, I only need to know the lower heating value.
No, Jane, you need to know the temperature of gases at the chimney. The hotter the gases, the lower the energy you get.
And that's all?
Not really. You must also consider other losses like those through the boiler walls to have a final calculation of the energy efficiency.
So, the heat input minus the heat of the flue gas, the heat of the ash, and the losses through the boiler walls give me the useful heat. Yes. With the heating value and the energy efficiency, I can calculate the amount of fuel. And now, what about the emissions released in the boiler? With the chemical composition, I can calculate the amount of carbon dioxide released to the atmosphere. A simple exercise I learned to do in the high school.
So, what Jane needs to know for her project is: first, the biomass heating value and boiler losses to calculate the energy efficiency and the consumption of biomass. Second, the chemical composition of biomass to calculate the boiler emissions. To learn more about the chemical characteristics of biomass as fuel, Jane arranges a visit to the Forest Science and Technology Center of Catalonia. At the CTFC, she meets Tanya, the head of the biomass analysis lab. In the way to the lab, Tanya explains Jane that the chemical composition of solid fuels is very complex.
So, what we do here is divided into two main analyses, the elemental analysis and the proximate analysis. The elemental analysis provides the content of chemical elements like carbon, hydrogen, nitrogen, and oxygen.
So, all I need to calculate the composition of flue gases when burning biomass, right?
Right. Now, let me show you now the next lab, where we do the proximate analysis. The proximate analysis provides information about the combustion performance of the fuel. It includes the information about moisture, volatile matter, ash, and fixed carbon.
Why moisture is so important?
When you harvest fresh biomass from forests or energy crops, its moisture content is high, maybe around 50%. After several months of storage, biomass loses water, and when you receive it to be burned in an oven or boiler, the moisture content should be low for an efficient combustion process. Water is an extra weight you are paying to be transported to your boiler, where it consumes energy for nothing.
So, the less moisture, the better, I understand that. And what is the dry basis?
Dry basis is the content of biomass regardless of moisture. It is assumed that the organic compounds and mineral matter remains constant while the moisture changes over time. Therefore, is a practical reference used by scientists and engineers to provide data about biomass independently of the water content it can have.
Okay. And in the data you showed me, the ash content of biomass is very low when compared with coal. Why should I care about ash?
First, because your boiler has a system for removing ashes. If you change your feedstock, you must be sure that this system will work properly. Second, and most important issue, because ash is the devil in the oven. Ash can produce slagging and fouling of the heat exchange surfaces. Therefore, ash melting behavior is something you should take care of.
Back to her office, Jane wonders how to skip all these analyses. After all, when using fossil fuels, you don't need to analyze the fuel, because there are standards and certifications. After investigating, Jane discovers several certifications. EN+ pellets are tested for mechanical durability, percentage of fines, bulk density, ash and moisture content, as well as the calorific values and the percentage of additives. All this to guarantee that pellet appliances will perform at their best. DEEN+ certification is also a good guarantee of pellets quality. And what about wood chips? Nowadays certifications for wood chips can vary from country to country. However, Good Chips, the first international certification for wood chips, started in late 2019, aiming to apply the same principles that EN pulls for pellets. At CTFC, Jane learned from Tanya that they make analysis of wood chips to give them the DBOSQ certification in Catalonia. Wrapping up. Jane has been investigating what she needs to know about the properties of biofuels for her project. The heating value, moisture, ash content, and elemental analysis are the key parameters she needs to know. Quality standards like EN+ for wood pellets guarantee these parameters to be within a predefined range. However, if she is going to use wood chips or agricultural residues, she needs to send a sample to the lab for doing the proximate and the elemental analysis, as well as the lower heating value. With this information, she will be able to calculate the consumption of biomass, the boiler energy balance, and the carbon dioxide emissions.